Welcome to the Race Bay, and indeed, welcome to some race bays. Now, here on this channel, we love talking about motorsport engineering, and where better to do some filming than here at West Surrey Racing, 16 times British Touring Car Championships, and we're here to talk about the BMW 330. This is BMW's famous 3 Series. As most of us know it, it's a nice practical car for the executive on the move, fitted out with fine leather upholstery and all the electronic gadgets. Which makes for some fantastic road cars, but these aren't road cars, these are race cars. These are cars built up specially for the British Touring Car Championship, and we're going to have a deep dive to look under the skin of these race cars. So now we're down in the race bays and joined by Dick Bennett. Dick, thank you for inviting us to the factory today. Fascinating setup here and a huge wealth of history in touring cars.
Yes, we've been doing it for a few years, but yeah, we moved from British Formula 3 to British Touring Cars in 1996. We initially started with the Works Ford Super Touring, then we switched to the Hondas, then we switched to MG Rover when the regulations changed, and then when the rules changed again, we've switched to BMW's Super 2000 E90, and we won our first championship in 2009 with Colin Turkington. We've been with BMW's ever since. From 2017 on, we've been assisted with BMW by BMW UK.
Here we have one that you made earlier, as they say. Taken through the process of building a touring car from scratch, what is the initial building block? What in terms of the chassis do you get from BMW?
The regulations, the BTCC regulations, you must run a production shell, you must run production doors, you must run production bonnet and boot. Then every car on the grid has similar subframe front and rear, but the shells we get from Munich. We have one here. Then there's a lot of work prepping them. They have to have FIA safety cage. That is designed by WSR to FIA regulations. We used to build all our own shells here, but it's more cost efficient now. We have a company, WPMS, Willie Paul Motorsports. He builds our shells to our drawings. So that's his professional business. We used to have fabricators full time, but with so many control parts now, it's hard to justify having those fabricators employed all year.
Okay, so that will then get you effectively a body in white with the roll cage. Now, when we're talking roll cage in touring cars, it's not just there for protection, it actually forms the chassis, the strength of the car itself.
It's quite crucial. We make it as light as we can, obviously, within the regulations, but also the stiffness of the shell is mainly done by the roll cage.
These aren't crash tested with the roll cage, but that's all done with computer simulation by the FIA, isn't it?
Yes, the FIA and Motorsport UK, we have to submit our drawings to them. They run it through a simulation program, computerized, and yes or no. So, but also the this current 3 Series BMW is a very strong chassis itself. We're quite impressed how good it is.
And then you start the fit out, and well, we'll talk about the subframes and the engine separately, but in terms of the driver's office, the driver's got a really unusual seating position. They're really far back. I don't think my seat even goes that far back on my saloon car. What's the thinking in terms of the driving position?
It's all to do with weight distribution and C of G. So we get the driver as low as we can, but also we get them back as far as we can. And there's a regulation, furthest most point of the front seat is not allowed to go beyond the rear squab of the rear. So we have it right within a millimetre of that. The regulations also with the roll cage, the B-pillar cage here, we have that tipped back 2 degrees to allow to get the seat back further, and that's the FIA regulation. So everything is taken to the limit of the regs. Because the BMW road car is actually 50-50, we try and achieve that with a race car. Up till we went to hybrid, we were achieving 50-50. Now we're 1 to 1.5% over. So another job this winter is to try and get it back to 50-50. But the regulations change quite often to not help us.
Moving on to the driver controls, obviously the steering wheel gets brought right back and the dashboard almost kind of disappears now in terms of what you would have spread across you in front of your executive BMW. You just have a small dash display.
Yes, the steering column is all bespoke made for us, designed by us. It also has a collapsible column in case you have a big front-on accident. The steering wheel is nothing as complicated as Formula One, but it is much more complicated than what it was 2 years ago, because now the BTCC regulations, we have to run hybrid. So there's several buttons on there all to do with the Cosworth hybrid system. They have a display here, which is for the gear lights, for gear shift. We have another Cosworth panel. It's all Cosworth equipment. All the cars have to run the same system. But the driver safety-wise, we have the nets. We've always had the net here, but now in the last years we've had to put a net in the middle as well. And you'll be able to see later there's the hybrid battery in there, which alone is 27 kilos. The whole hybrid kit alone is about 60 kilos in weight. So most of that lives in where the passenger normally sits.
And that's your job for the winter. Going back to the summer, driver comfort, obviously they've got a lovely comfy seat there. I see a big hole in the back of the seat. Is that ventilation?
Yes, that's for driver cooling. Some drivers like the cooling into the helmet, some have them into the lower seat, some have a fan blowing on them on their face, so it depends on each driver what they prefer.
And the British summer, of course.
Yeah, occasionally, but we did have a couple of hot races, but generally we probably need heaters at Brands Hatch.
So that's the shell and everything inside with the driver. Let's go now and have a look at the front of the car with the subframes and the suspension.
Yeah, okay.
So Dick, we've now got the complete front of the car sat on a trolley in front of us. Obviously now the standard BMW wouldn't be like this. And in fact, going back in history, touring cars wouldn't have been like this either. So why have we switched to a subframe now?
The early days when we ran the E90, that was very much a production BMW engine. Now, since the rules changed 2012 to NGTC, we called it, New Generation Touring Car, the agreement was then to equalise cars. Some cars, road cars, were easier to be made to a race car than others. So every car on the grid now, no matter whether it's front-wheel drive, rear-wheel drive, has to run the same front and rear subframe. RML are the people who produce them for Toka, and they do the wishbones, uprights, subframes, steering rack. The brakes are all AP as well, so the subframes are a crucial part. We're not allowed to change anything here, but it's how you design your shell to hold the subframe is an important part as well.
Okay, so we've obviously got a whole range of production cars racing now in British Touring Car Championship, all very different structurally inside. But it's not that this subframe actually attaches to the front of the body shell that's had maybe bits cut off. It's actually connecting to an extension of the roll cage.
Roll cage, yes. And that's one of the crucial design parts we do, is the stiffness of it all when it's installed, to make sure it's doing what we want it to do. And what proves it to me, or to us, is that when you make a small adjustment, some people think a touring car's not like a single-seater, but trust me, we can change the ride height 2 millimeters, 1 degree of wing, 0.2 of a camber, and the car's better or worse.
Wow.
So, and that's due to the stiffness package of the whole installation.
And that's also due to the fact that although this is a standard subframe, there's a lot of adjustability for the suspension geometry. Obviously, you're running rear-wheel drive, slightly different weight distribution to the front-wheel drive cars. So it's all quite different. It's all super secret stuff as well.
There is a lot of permutations within the geometries, from roll centres to dives and squats and camber change. So yeah, it's quite a crucial part on how good a touring car works.
And it's fascinating that touring cars now is effectively given the front and rear subframes are identical. It's obviously modified slightly so that you can get your different orientation of engine, and we'll go and have a look at one of the rear subframes in a moment as well.
Yes, yeah. We're north-south being a BMW. The production road car is north-south. The packaging from the front of the subframe forward is all down to us. The radiator positioning, although it's tied to a regulation as well, the intercooler positioning and all the ducting at the front is all WSR designed.
Okay. And we were speaking earlier about the intercooler, which you can see stacked above here. Now that is a spec part to a degree, isn't it?
Yes, the actual core of the intercooler is a control part. So every car on the grid again has the same core, but then it's down to each team to how they install it. So the end tanks are designed by us.
And again, just showing how all this standardisation just makes this sport so competitive and affordable at the same time.
Yes, it's for here, for example, there's a separate water system for the, they call it the LTR, with a pump each side. We have 3 separate water systems on the car now. We have one for the engine. Then we have a complete separate system here for cooling the EV motor, which is in the bell housing in our car. And then this one is a separate system to cool the hybrid battery. So it's quite complicated now in getting everything packaged and working.
So you'd have little tiny radiators fed off of the ducting at the front?
Yes, we call them an LTR, low temp radiator.
Oh, I see.
And that's again a mandatory TOCA part that every car has to carry 2 of them.
Okay, so this is the front. Let's just go and have a wander over and have a look at one of the rear subframes as well.
Yes, yeah.
So we're now at the other end of the car. This is the rear subframe. And again, would be exactly the same if it were a front wheel drive, obviously except for the differential.
Yes, yeah, again, every car has to run the same subframe, but being rear wheel drive, BMW tradition, we carry the diff here. Again, it's like front wheel drives, it's an extract part. Very good gearbox, I must say, very good. We can adjust. The old days when we ran touring cars, you used to have to take the diff apart to do preload. Now you get in with a little spanner and you can adjust the preload.
Is that the little sprung?
Yeah, there we go, down there, yeah. So
and that's it.
That is, makes life a lot easier.
That does make it a lot easier. So looking at some of the architecture, you've got double wishbone suspension with the push rod setup. These are spec dampers?
Yes, yeah, every car again, they're Penske dampers, but each team is allowed to develop them, but only with homologated parts. So you have I think a selection of about 4 different pistons, and the shims varying from next to nothing through to whatever you want.
And with so many spec parts, this and the suspension geometry is where you start to find the magic in setting the car up, isn't it? It's how you set your dampers, how do you get your suspension geometry working?
Correct. Dampers are quite crucial, and Steve, our chief technician, he's been developing dampers. We are running one of the 4 cars with a slightly different spec. We're testing, playing. The other 3 are running out, which is again new for 2023. A different spec to what we ran in 2022. As the tyre from Goodyear changed their spec, that affects how the dampers work. So we are tuning the dampers to suit a tyre, and also the different track surfaces.
Something else on here, which I hope you can just see at the very back here, has nothing to do with suspension. At the back you have the air jack, and you have those on the roll cage inside the cockpit at the front?
2 at the front, 1 at the back, so when you do a pit stop, nothing like the speed of F1. But if we change wheels in a race, because also we're restricted on the amount of people you're allowed to do pit stops, we do a hot pit stop in about 4-wheel change in about 20, practicing we do it in about 17 seconds, but in reality it's about 22, 23 seconds.
Which is still massively impressive.
Oh yeah.
It's such a big vehicle and a limited number of people.
Yeah.
Okay, so now we're going to want to go away and talk about the next thing, which attaches to the front here, which is the engine and the gearbox.
Yes, yeah.
Now we're at the sharp end of the car again. The subframe's in, the engine's in, and Dick, we've got a bare engine here to have a look at. Now, British Touring Car Championship has always been about production engines. What can you do to run an engine in the championship at the moment?
You're correct. It is, the rules are it has to be a 2-litre production engine, which this is. We use a BMW B48 model engine, which is a fantastic road car engine, but also it's made a fantastic race engine. The regulations are 2-litre, but you could use an engine from 1.6, I think, up to 2.4 within the family. So, but this actual engine we use is a 2-litre production turbo engine.
Yeah.
So it makes a very good basis. It uses production BMW valve, cylinder head, production crankshaft, MBE Neil Brown Engineering, developed the engine, so they've got racing rods in it, racing pistons and valve springs. We actually use the road car fly-by-wire throttle body as well. The oil system is all BMW. It has a electric water pump, which is BMW, so the majority of it is a BMW road engine.
And there is regulations that limit what you can do. Now, I can remember touring car engines used to be absolutely down on the floor of the car. This is raised up and it still has a wet sump. Why would the engine be so high up in a race car?
It's actually the current regulations. The engine has to be as per your road car. And I've actually been campaigning for dry sump. I used to build race engines, but the regulations are it has to be a wet sump. So that's quite a lot of work for the engine builder because of oil surge problems. They're going so fast through corners.
Yeah.
Yes, it is sitting in the chassis, but what you're talking about is the Super Touring, which was a fantastic engineering exercise for designers. I used to love it, but the budgets just got out of control. Whereas now the budgets are controlled to a level where it makes the racing, better.
And another thing that's fixed is the cam lift, and you're running your dedicated Neil Brown cams?
Yes, there is a maximum regulation of 11mm valve lift. MBE designed the camshaft to be 11mm valve lift. So everything's done to the limit of the regulations. Compression ratio is fixed at 11:1. The Super Touring days, I believe one of our engine was up around 14:1. So it's done now. As I said earlier, we can get through a whole season on one engine. So we do about 5,500 kilometres per season.
And again, as we've spoken so much about, you have specification parts such as the turbocharger, and also you have a limit on how different all these engines are apart. Because again, you can have your road car engine, you can have a specific touring car engine as well, and they're all within a few horsepower of each other.
Yes, the TOCA, the organisers, they flow test all the engines before you run them on the inlet side to check how much air gets in, and they determine your boost level for your turbo. And it's pretty accurate. They get it pretty close. Sometimes different teams have a little bit of a gripe about it, but generally, like last weekend at Silverstone, qualifying, there was 4 cars within, I think, 0.04 of a second.
Wow.
And they're all different make chassis, so it's
working.
And they run on control tyres, so that helps as well. You either run some meetings we have a soft tyre, generally the medium compound, and then places like Thruxton we have to run the hard compound tyre for safety.
Yep. Okay, so that's the power unit. What kind of headline performance figures are we talking about for this?
I can't divulge that. It's a very good engine. We believe all the engines are within 5 horsepower of each other, and if MBE don't give us dyno sheets.
Okay.
They build them, dyno them, but we think most engines are up around the 390 horsepower.
Okay, so we've actually got the engine backwards. You're looking at the back of the engine, which would then go back along the car, so you can see the clutch there. Now, it's not just a combustion engine now, is it? There's also the hybrid system, which Cosworth have now introduced.
On the clutch, that's again another control part. It's a carbon clutch from AP, very good clutch. As you say, behind that, for the last 2 years, we've been running hybrid. So for a rear-wheel drive, the EV motor is actually in the bell housing. On a front-wheel drive, it's separate to the gearbox up under the bonnet. Ours is much harder to get in and out if we have any issues. We used to have some temperature problems, but now we've resolved them by using 3D printed little cooling ducts and that. So it's been great. We have a technical alliance with Midland 3D, and they've been producing a lot of 3D printed parts for us, which has been fantastic with the speed you have to develop new parts.
And then leading back on from that, within that bell housing you were talking about, is the sequential gearbox, which oddly is the same for the front-wheel drive and the rear-wheel drive in essence, even though they're in very different installations.
It's Extract from Newbury, fantastic company producing it. The gear ratios are virtually identical, front-wheel drive, rear-wheel drive, so TOCA can then monitor to keep accurate. They can log in and see what speeds, what gears you got in, because we have to homologate what ratios we're running. So then we have to hand that form in on Saturday. If we change ratio Saturday night, we have to inform TOCA. But yeah, we use the longitudinal 6-speed extract. Everyone's 6-speed sequential with a gear lever still. There has been discussions on paddle shift, but the regulations are we still have a gear lever.
Excellent. And that's then rides through to the drive shaft to the rear subframe that we were speaking about earlier.
Yes, the prop shaft, I know some sports cars run a carbon prop shaft. We're not allowed. It has to be a steel prop shaft, which is, again, we have an outside company make it to our specification. The early days when we went turbo, we had a few prop shaft failures because of the extra torque and power. So we've had to up the diameter and the gauge of the prop shaft to cope with the power.
And developing's continuing.
Yes.
Fantastic. Yeah. So that's what goes into making a championship leading British touring car. Many thanks to Dick Bennett and the team and some of the ex-drivers here at West Surrey Racing. Hope you've enjoyed this video here on the Race Bay and come back for many more.